Hi everyone, welcome back to MAM Pathshala. Today's video is gonna be a comparison video between DED and LPBF. Before going into that, always remember you should have a generalized outlook on these two processes, as these two processes have a very different working principle, but these two are the most commonly and widely used metal additive manufacturing in the industries. So any additive manufacturing process can be divided into its few basic units. Also, additive manufacturing has the major two aspects. One is the material aspect, another one is the energy aspect. So I am going to divide these two metal additive manufacturing or MAM processes into four basic units. One is the energy source, the next one is the energy delivery system, the third one is the material delivery system, and the fourth one is the manipulator. So let's start with the first basic unit, which is energy source. For DED and LPBF, laser is used as an energy source. However, arc electron beam can also be used for these two systems, but in this video we will be focusing on the laser only. So LPBF is known for its micron level accuracy. But how this micron level accuracy is achieved? We have talked about the galvo scanner, the F theta lens in our last video, but these things are responsible for the fast movement of the laser beam over the powder bed. But the micron level accuracy can be achieved by the laser process parameters. For example, the mode or transverse electromagnetic mode, which is also known as TEM. So you'll see somewhat like TEM 00 or TEM 01, 1, 2, 2, 3, so on. So what are those? I'll be talking about that. The next one is laser focus spot dia. Wavelength also plays an important role. So these three are the main important parameter of the laser, due to which we can achieve the micron level accuracy. In case of LPBF, fiber laser is used. In case of DED also, fiber laser are used. Apart from fiber laser, diode laser, ND arc laser, CO2 lasers are also used in case of LPBF. But these are some types of laser. So depending upon the material that are being used to print, depending upon the absorptivity of the material, we use different types of laser. Here let's focus on the fiber laser system. So for LPBF, we are using a fiber laser which will be focused over the build plate. So this is the focus spot, and this diameter of this focus spot typically is in 100 to 120 micron, as I also mentioned in my last video. This 100 micron focus spot will result in the micron level accuracy in the printed part in LPBF. But TEM is also important. How? If you see the intensity profile of the laser beam at this focus spot, it somewhat looks like a Gaussian profile. So this is the focus spot, and this focus spot has a Gaussian type of intensity profile. If this focus spot is having only one peak in its intensity profile, it will be called as TEM 00, which is also called single mode laser, which is preferable for any type of deposition to get the micron level accuracy. If anyhow the focus spot is having multiple peaks in its intensity profile, it will be called as multi-mode laser. So these are few terminology which we use to characterize a laser beam. I'll cover these topics in a separate video. For the time being, you just remember, if the laser beam is having only one peak in its intensity profile, then only we can get that micron level accuracy. There is also another thing, which is the powder particle size. The powder particle size distribution for LPBF is also in the range of 15 to 45 micrometer, which is also a reason to achieve that micron level accuracy. So all this parameter together responsible for the micron level accuracy. Generally, LPBF machines work with 300-400 watt power, which is certainly a high power, but it's low in terms of material processing applications. In the low power, achieving a single mode or a one peak Gaussian laser beam is easier, while DED deals with higher power, sometimes in kilowatt. In that case, the lasers are multimode due to the fiber coupling of multiple single emitters or single mode lasers, which deteriorate the property of the laser and the printing accuracy. However, you can achieve single mode laser with a better optical arrangement. So that's another thing which is important in case of DED. DED needs higher power because the DED deals with higher powder particle size distribution, somewhat around 45 to 120 micron. Sometimes it's 40 to 102 micron as well. Focus spot which is needed to melt those powder is larger. So the focus spot of the laser is larger in diameter, somewhat around 300 to 400 micrometer, which is bigger than LPBF. So in DED we cannot achieve that micron level accuracy like LPBF. However, the working principle of DED and LPBF is completely different. Also, in DED, along with fiber laser, diode lasers are also used. Depending upon which material you are printing, because the material should have a larger absorptivity at that particular wavelength of the laser. So this is why diode laser is also used. For diode laser, if you go for higher power, you'll get a top hat type of intensity profile, which looks like this. This is the focus spot. This will be the intensity profile. If you are going with fiber laser, then you'll get this type of multimode laser due to the high power. Because high power is achieved by fiber coupling multiple single sources. So if you are going for higher power, you have to couple a lot of single mode fiber lasers or diode lasers. For diode laser, the physics is much more complex. I'm not going into that part. But for fiber laser as well, you have to go for more coupling that will deteriorate the quality of the laser. So this TEM mode is something by which we characterize a laser. We define the property and the quality of the laser. So as a recap, one is the purpose for which you are using the 3D printer. And another one is the powder size, which will again depend on the purpose for which you are using that printer, and depending upon the powder size you will select the laser and its power, type of laser, etc. So all these parameters together influence the quality of the printing and the process as well. So this is why it's important to know the basic components of two different metal additive processes, because these are the most important process for printing a metallic part. So these are the few similarities and differences between DED and LPBF based on the energy source. However, I have mentioned many a times that LPBF works with very high speed. However, DED deals with higher powder particle size distribution. So the laser spot die is much bigger in case of DED. The speed is less. So are they related to each other? Is it a limitation for the DED process that we are using higher powder particle size? Or as DED is used for the cladding purpose, cladding needs higher powder particle size distribution? What do you think? We'll discuss upon this topic in my next video. Till then, if you have any suggestion or doubt, please comment down below. So let's meet in my next video. Till then, stay tuned and happy printing.